So demand for most products happens over time. So naturally, we can think of demand forecasting using time series analysis. And remember, what we're doing here is looking for patterns. So one of the best ways to look for patterns is, because we're all human, is visualization tools. And so, as I said before, the best thing you can do with data is to map it out, graph it, because visually we can pick things up much faster a lot of times than a computer can pick up a trend. So what I'm showing here is sales by month for a low-cost food item, and it's for North American demand. So on my horizontal axis is the time from, you see, December 2009 all the way up to fall just before, I think it goes to November 2012. So about 3 years worth of data here. And on the vertical axis is the number of units sold, and you can see it peaks to 11 million, just over 11 million up here in the summer of 2012. So if you look at this, you see an obvious trend. You see some kind of seasons. It looks like during the summer I might have some peak times, right? Here in the summer, here in the summer, here in the summer. And conversely, it's kind of low in the winter. So you can kind of see that there's some kind of patterns here, some kind of seasonality. And just because these follow the seasons, summer and winter, seasonality isn't just restricted to the 4 seasons of the year. But let's go a little deeper. Let's look at it now by week. And so all that I've done is broken up in each point. It's connected by a line, but each point is the amount of sales nationally per week. And you see there's even more volatility. And you would expect this because I'm disaggregating. Remember in our last lesson we talked about how you aggregate, it kind of smooths things over. Well, as I disaggregate, it tends to, you see the volatility. And then even more so if I go by day. And so not only do we see this seasonality, let me just highlight it over the course of a year, right? This is 3 years. But you can also see that there's some kind of volatility or seasonality maybe within a week, that there seems to be a weekly pattern. And this is something we can explore further. But the point here, using visualization tools really helps you spot something quickly, and especially for patterns. So if I break this into a bar chart, this is the same data. And what I've done here is I've broken it into quarters, Q1, Q2, Q3, Q4. And you can see the months that fall with that, and then the total units sold. Looking at this, it's obvious there's some kind of pattern. We sell a lot in the summer, spring and summer months, right, in this time. And we don't sell too much here, and a little bit in the early spring, late winter, a little bit more. But you can see there's definitely seasonal differences here. But also, as we said earlier, there seems to be some seasonality here within the week. So if I look at day of week, and all I did was classify all the sales on a Monday, Tuesday, Wednesday, and so forth, obviously the weekends, they don't do much. Because this data is actually not at the retail store. It's what is shipped out to the retail stores from the manufacturing plant. So you can see that there's definitely very little demand on the weekends. In fact, you could probably just knock those out. But then you could see that on Friday, there's much lower demand than on a Monday or a Tuesday. So there is seasonality both across the year by month or quarter and within the week. So this is very important because we can use this to forecast, because the whole purpose of looking at patterns in the past is to see how they will project to the future. So here's my same data, and remember, this is just the past 3 years. We're assuming I'm in November 2012, and what I want to figure out is, what does the future look like? What is it going to look like? Because I want to use my patterns in the past, the seasonality, to predict and estimate what my pattern will be in the future. 2 things I want to point out. First, notice that there's a range here. Remember how we talked about how the importance of a range? It's a very big range, but still, it gives you an idea of the level of confidence. You should always try to include that in a forecast. The other thing is, and this is just a very quick estimation that was done, is that they're estimating with this model that in the spring and summer of 2013, it's not going to be as high of a peak as here in summer of 12. You can see it kind of levels out. It's kind of taking not quite the average, but it's balancing between those two. And we'll talk more about that, because what this forecast is saying is that yes, this peak in 2012, it was there, but it doesn't mean that I'm going to go up to here in the next time. So you can see here that the forecast, and we'll see this more and more when we go into time series, is balancing off new information, right, with some of the old information. So what will we talk about in this lecture? Well, we're going to talk about time series components, those patterns we're going to be looking for. Then we're going to talk about 3 types of forecasting methods: cumulative forecast, naive forecast, and moving average forecast. This kind of sets the stage for all the other forecasting methods that we're going to work with. So let's get started.